Hi, in this video we'll learn how to solve exponential equations. So these are the exponential equations and we'll solve these equations for x. Now before solving these equations, I want to tell you about an important property which we'll use in this video. It is called one-on-one property, and which says that when you have same bases on each side, the exponents are equal. So let's say, suppose if I have an example, 2 cubed is equal to 2 to the power x. Now, what will make this equation true? What value of x will make this equation true? Well, the only value which will make this equation true is x should be 3. X should be 3. If x is 3, then this equation will be true. That means you see that you don't have the bases here. I mean, when you have the same bases, they just cancel out. They just go away. And you are only left with the exponents. So you just write 3 is equal to x, or x equals to 3. So this is called one-on-one property, in which is when you have the same basis, like you have the same basis, 2 is the base and x and 3 are the exponents here. So when you have the same basis on each side, the exponents are equal here. So this is the important property which we'll use to solve these equations. Now let's take a look at the first example here. I have 2 to the power 5x is equal to 8 to the power 2x minus 4. So first of all, the best way to solve this is I need the same basis. So that I can make the exponents equal. I can write the exponents equal. So I need the same basis here. I have 2 to the power 5x. I can't do anything to this. Let's write this down first, 2 to the power 5x. But here I have 8 to the power 2x minus 4. Now I can write, how do I write 8 in the form of 2? I can write 8 as 2 cube. 2 cube. I didn't change anything because 2 cube is equal to 8. And then I write the parentheses and then the power. So the exponent is 2x minus 4. So this is just a different way of writing 8. Okay, I wrote 8 as 2 cube, and then I have the exponent 2x minus 4. Now here I have 2 to the power 5x, which will stay as it is. And here, now remember the law of the exponent. Law of exponent says that if you have a to the power m, the whole raised to the power n, then you can write them as a to the power m times n. That means you just multiply the exponent. If you have an exponent raised to another exponent, then you can just multiply the exponent here. So we can do the same thing here. We can just multiply the exponents here, but we have to be careful here too. And then I can write this as 3 times 2x minus 4. Now it's necessary to write this inside the parentheses because I have to distribute 3. I have to distribute 3 inside the parentheses. So 3 has to be multiplied with 2x, and then 3 has to be multiplied with negative 4. So now next step it will be, let's write 2 to the power 5x is equal to, now we have to distribute 3 inside the parentheses. So 3 times 2x is going to be 6x, and then minus 3 times 4 will be 12. Now you can see that I have the same basis here. That's what I want. I have the same basis now on each side on each side. So what I can do is I can, by using the one-on-one property, when you have the same base on each side, the exponents are just equal. So I can just get rid of the bases here. They just go away. And I can write that 5x is equal to 6x minus 12. So the exponents are equal and the bases just go away. Now, this is a simple equation. I can solve it. This is a simple equation. I have to solve this for x. So let's get rid of 5x from the left-hand side. So subtracting 5x on both sides, subtracting 5x here, this will cancel out each other. I have 0 on the left-hand side. On right-hand side, 6x minus 5x will be just x minus 12. Now I need to solve this for x. So adding 12 on both sides, this is going to be 12 is equal to x, sorry. So my final answer is x equals 12. Now let's say, let's solve this next example. I have 2 to the power 4x is equal to 32 raised to the power x plus 1. So I can, what I can do is, let's write this as 2 to the power 4x first. And then I know that I can write 32 as 2 to the power 5. Now what I'm doing is I'm trying to make the bases equal. I want the like bases so that I can cancel, so that just the bases go away and I have the exponents. I can bring down the exponents here. So I can write 32 as 2 to the power 5. Then I have to make sure that I have written 32 as 2 to the power 5. And then I have the whole raised to the power x plus 1. Okay. Now, again, we do the same thing. We will use this property a to the power m, the whole raised to the power n is equal to a m times n. So we will multiply the exponents here. So 2 to the power 4x is equal to 2 raised to the power 5 times x plus 1, since we are multiplying the exponents. So we will distribute 5 inside the parentheses. I can write this as 2 to the power 4x is equal to 2 to the power 5 times x is going to be 5x plus 5 times 1 is going to be 5. Now you can see that I have the like bases. They just go away. I can cancel them out and I can bring down the exponents here. So this is 4x is equal to 5x plus 5. Now this is a simple equation and I have to solve this for x. Subtracting 4x on both sides here, subtracting 4x, this will cancel out each other. I have 5x minus 4x is going to be just x plus 5. And on the left hand side, I have 0 here. So since I need to solve this for x, I can just eliminate 5 from the right hand side. So subtracting 5 on both sides, this will be 0 minus 5 will be negative 5 is equal to x, because positive 5 and negative 5 will cancel out each other. So the value of x here is negative 5. This is the final answer. Now let's take a look at this example here. I have 81 to the power 2x minus 3 is equal to 9 to the power x plus 3. Now again, I can change 81 in the form of 9. How do I write 81? So I can write 81 as 9 squared, the whole raised to the power 2x minus 3. So I just changed 81. I rewrite 81 as 9 squared, and then I have the exponent here on top. This is equal to 9 to the power x plus 3. Again, I need to distribute. I have to multiply the exponents, since using this property, a to the power m, the whole raised to the power n is equal to a to the power m times n. That means I have to multiply both the exponents. I'm doing that here. So this is going to be 2 times 2x minus 3 is equal to 9 to the power x plus 3. Now multiplying, distributing 2 inside the parentheses, this will make 2 times 2x is going to be 4x minus 2 times 3 is going to be 6 is equal to 9 to the power x plus 3. Now you can see that I have the same basis, like basis, they just go away. And I can write the exponents here. I can bring down the exponents. So 4x minus 6 is equal to x plus 3. Okay, so now I need to solve this for x. So just subtracting x on both sides, because we have x on both the sides. So let's get rid of x from this side. So x and x will cancel out each other. 4x minus x is going to be 3x minus 6 is equal to, I'm left with positive 3 here. So I'll just write 3. And then I have to solve this for x. How do I get x by itself? Adding 6 on both sides. Eliminating 6 from the negative 6 from the left hand side, adding 6 on both sides. Negative 6 and positive 6 will cancel out each other. I have 3x on the left hand side. On right hand side, I have 3 plus 6, which will make it 9. And how do I get x by itself? I can divide both sides by 3. So 3 and 3 will cancel out. I have x is equal to 3. So that's my final answer. So this is how you solve the exponential equations. That's all for this video. Thank you so much for watching. Please like, comment, and subscribe to my channel. I'll see you in next video.